Good afternoon and welcome to the week 13 lecture video. Let's go ahead and take a look at the quiz. Well, hold on. First of all, the agenda. So let's start off by going over the three-pronged approach that we always use, okay? So prong one is theory. This is our approach to the class, the three-pronged approach to the class. Prong one is theory. So you get this through reading the textbook and taking the quiz and then quiz review, which I jumped the gun on, but we're going to do. The second prong is SPSS. Okay, the SPSS lecture notes were supposed to get you ready to be able to read the output that you needed to read for your results section. For some of you, this is review because you had SPSS potentially in previous classes. Others of you, this was sufficient to get you to where you needed to be in order to read the output and use the results writing templates to actually write your results paragraphs, 3 paragraphs, right? The third prong is the research paper. And how do we get through this research paper? Week by week, piece by piece, through these lectures, through you participating in discussion forums and peer reviewing each other. And then the other assignments, which are the rough drafts. And that's where I give you the feedback that you need and we kind of go back and forth, okay? And then eventually you get 100% because you make all the changes that I need you to make, either by the sufficiency of the comment, the assignment comment, and from there you're able to just say, oh, okay, I get it, I'll do it. Or you ask questions via email or you come to office hours. So it all works out, right? So this is our three-pronged approach to research methods. Okay, quiz 6 is what we're going to review. In a single group design in which treatments are alternated AB-AB design, what is the purpose of conducting multiple initial observations before any treatment is given? To establish a baseline for comparison post-treatment. Okay, I'm not going to go into that. What is a confound in an experimental study? It's an extra variable that could explain result differences between the groups. And we already learned about confound at the beginning of class, right? When I was talking about that nice experimental paradigm where you randomly assign people to a treatment and a control. If you remember, what I said is, let's say your experiment started, I believe it was 7 a.m. and you took the first 100 people, okay? And there's 100 people that showed up. You took the first 50 people and you just threw them in the treatment, and the second 50 people and you threw them in the control, okay? So you didn't use random assignment. The problem is now if you see a difference between the treatment and the control, is it because the 50 early people are more conscientious than the second 50 people, or is it because of the treatment versus the control? And how do we get around these confound variables, or these what are sometimes called third variables? Okay, we get around these variables by using random assignment. So I take the first person, I randomly assign them to either the treatment or the control, the second all the way through the 100th person. And therefore, at least I know I'm cutting out the effect of conscientiousness on the results and other variables too. And that's the whole point of random assignment, to get rid of confounds. Which type of statistics helps researchers to estimate the effect of sampling errors in their results? This is called inferential statistics. Okay. Here's the thing. In samples, we may see a difference because there's error, because they're potentially biased. But we use inferential statistics to do the following, okay? What's the probability of getting the sample data that I got, like the sample correlation or the sample difference between the two variables, if there's no relationship in the greater population, or there's no difference between the treatment and the control in the population, okay? And in statistics, we say, if that probability is less than 5%, p is less than 0.05, then we say, well, it's highly likely, or this result is so unlikely, okay, of us getting what we find in the sample if there's nothing going on in the population, that we say to ourselves, well, there must be a correlation, there must be a difference, right? And if we find that the probability of getting the sample data that we got, let's just stick with sample correlation to make it simple. Let's just say the probability of getting the sample correlation that we got, if there's no correlation in the population, is greater than 5%, at that point we say, well, it's actually very likely that we'd get this correlation in the sample if there's nothing going on in the population. Therefore, we retain the null hypothesis, and we say, at this point, there's insufficient data to conclude that there's a significant correlation. Or we just say, there's not a significant correlation in the population based on these sample data. So that's the whole point of inferential statistics, right? Again, let's simplify this. In inferential statistics, you make a statement about a larger population based on sample data. And you do that through the use of the p-value, which I just explained. If a researcher asks participants to name the country in which they were born, the researcher is using which scale of measurement? This is nominal, right? So it's just like the variables religious affiliation or race or gender. These are all nominal variables. We can't rank them. You hear children at play in the background. There you go. I don't know if you could hear that. When reporting a percentage, it is a good idea to also report the underlying number of cases. Yes, I totally agree. Okay. If you say 50% of people believe X, 50% believe Y, and it's actually one person believes X and one person believes Y, well, that's not very convincing, right? Okay. It's kind of like when you're looking at reviews, right? Let's say it's in stars, but let's say something has 5 out of 5 stars, so it has 100% rating. Well, if it has 100% rating with one person, that's not as convincing if it has 100% rating with like 3,000, right? So think of it that way. Which of the following is the name of the curve that is symmetrical? Okay, symmetrical means the normal curve. And in a normal curve, the mean, the median, and the mode are all equal. They're all in the center, okay? Which of the following is useful for describing the averages of skewed distributions? This is the median, okay? So the mean is very reactive to large values. And you could test this, right? Okay. Take 4 numbers. 5, 10. Take 5 numbers. 5, 10, 15, 20, and 10 million. Now take the average of those 5 numbers. The average is going to be huge, but the median is just going to be that middle number, okay, which I believe I said was 5, 10, 15. You see, so that 15 would be more representative of these 5 data points because this number is a huge outlier. 2 groups can have the same mean but different standard deviations. This is true. And think of it this way, right? Okay. If a sample has 5 values and they're 5, 5, 5, 5, 5, the average value will be a 5. The standard deviation will be a 0. It's a 0 because it means there's no variability. Okay. You could have another distribution with other numbers besides 5, so there's variability, But when you take the average of those numbers, you get 5. So that's just an example of how distributions can have the same mean, but a different standard deviation. What is interquartile range? It's the range of the middle 50% of the data. And the best way to understand this is to draw out a box plot, right? The box plot has the min, the Q1, the Q2, the Q3, the max, right? And you can draw the mean in. But the important thing is the min to the Q1 contains 25% of the data. The Q1 to the Q2 contains 25% of the data. The Q2 to the Q3 contains 25% of the data. The Q3 to the max contains 25% of the data, right? So now just do the math. The Q1 to the Q2 is 25%. The Q2 to the Q3 is 25%. Well, the interquartile range is the Q3 minus the Q1. So it literally is giving you the middle 50% of the data. Which of the following is used to describe the statistical significance of results? The p-value, and that's what I was just talking to you about when we were talking about the importance of inferential statistics. Making a statement about a population based on sample data, but the key is to use this p-value. Once again, I'll just restate it because I think it's very important and I think a lot of people don't understand. Let's just go with something simple, a sample correlation. Let's say we found a sample correlation. Okay, what's the probability of getting the sample correlation if the population correlation is 0, meaning there's no relationship? If the probability is less than 0.05 or 5%, okay, then we conclude that the population correlation is not 0, okay? That it's something like the sample correlation, meaning there's a relationship. If the probability of us getting the sample correlation is p is greater than 0.05 or 5%, then we say the population correlation may be 0. It may be something else, but it may be 0. So based on that information, with that p-value being greater than 5%, we can't conclude that the population correlation is not 0. So that's how we look at inferential statistics. We can make a statement about a larger population based on sample data. And how do we do that? We use this concept of the p-value that I just explained. Which of the following is a way to say a researcher has rejected the null hypothesis, right? So I believe everyone gets this, right? Because you work through your results section. P is less than 0.05, reject. There's a significant correlation or significant difference. It all depends on the analysis you're doing, right? Okay, P is greater than 0.05, retain the null hypothesis. There is not a significant difference. Okay, I think that's good. Definitely let me know if you have any questions. I'd be happy to answer them, but there's your quiz. Okay, so the week 12 discussion had to do with the tables and figures. So I had one person email me and say they were having issues figuring out how to display their table of figure. So you can add an attachment. So that probably would have been the easiest way, although it seemed like some people were successfully embedding their table and or figure, and some people were not successfully embedding their table and figure, meaning it definitely was not following the template. So if you want to resubmit, you can. But that being said, I will be giving you table and figure and discussion feedback after the results rough draft feedback, okay? So just let me know if you have any questions about the week 12 discussion, either via email, of course, and or by office hours. Okay, so I gave you methods rough draft feedback. So definitely see your assignment comments and feel free to email me if something's unclear. I've already assisted a few students. The big thing is look at your hypotheses, figure out what variables are in your hypotheses. You need a measures paragraph for each variable in your hypotheses. I'll give you a great example. A bunch of you, I know you have support for same-sex marriage in your hypotheses, and you included every other variable, but you did not include that variable. That needs to be included. So that's like a good trick. So if I made a comment about that, look at your hypotheses and literally write out every single variable you see written, and then realize for every single variable, you need a paragraph. And feel free, either resubmit the whole methods rough draft and I'll get back to you during my next round of going over rough drafts, which will be the results rough draft. But you can also shoot me an email directly and I'll get back to you. Okay. Specifically, don't attach your whole document. Send me like, I rewrote this measures. Does this look good? Just don't send me the whole thing. If you're going to do that, just re-upload it in the method section, then I'll get to it when I can, because that's something I can't really answer off the cuff. I really have to sit down and methodically go through it. And again, with all these rough drafts, please resubmit, and I can give you further corrections or whatever needs to be done in order for you to get full credit. And a lot of you have already received full credit on your various rough drafts, so that's a good sign. It means your paper's coming together. If you still need to resubmit, get it done sooner than later. Okay, how do you write a paper? You write it. Okay, I always have this conversation with students. The hardest part of writing is to actually write. So just make sure you get it done. You'll feel a lot better just getting it out of the way, so it won't be in the back of your mind. I do the same thing. I'm a writer. I've written a few books at this point. Nothing big, nothing famous, but just I'm trying to just get myself out there a little bit, and it's hard, but you just have to write. Okay. So your next round of feedback will be given by this Friday, and it will be based on your results section. So if you haven't submitted that, make sure you submit it. By Friday, I will give you feedback on your results section, and I'll email you once that's done. Okay, so now we're done with the results. We're done with the tables and figures. So what's the next part of the research paper? It's going to be the discussion. Okay, and the first part of the discussion, that's all we're going to talk about today, is you restating your findings in a way that anyone can understand. And I think a lot of you did this, like when you were doing your literature review, you didn't necessarily like look at the results section and like, work your way through the statistics. I told a lot of you just look at the first paragraph or two of their discussion, because according to APA style, you have to restate your findings in a simple non-stat language. And I'll show you what that looks like. So again, these are based on the results writing paragraph. So I just wanted to make it really clear and kind of build on what we already know. So let's say your hypothesis, right, which is in your introduction section, says, based on past research, it is hypothesized that liberals will tend to support the legalization of medical marijuana more than conservatives. Okay, so then an assessment of that hypothesis, that would be in your results section. So this would be your corresponding results section paragraph for this hypothesis. It would say, a correlation examined the relationship between political orientation and support for the legalization of medical marijuana. As predicted, there was a significant correlation between political orientation and support for the legalization of medical marijuana. R with an N of 507 is negative 0.17, P is less than 0.05, such that liberals tend to support the legalization of medical marijuana more than conservatives. Okay, and actually, really what you should say here is such that liberals tend to significantly support the legalization of medical marijuana more than conservatives. So actually add that word, that's more appropriate. So now to restate your findings in the discussion section, you would simply say, as predicted, it was found that liberals tend to support the legalization of medical marijuana more than conservatives. So do you see that? You go from hypothesis, and then this is your stats language, okay? And then when you restate this finding in your discussion, it's just one sentence per finding, really, okay? As predicted, it was found that liberals tend to support the legalization of medical marijuana more than conservatives. Okay. So let's say you had an independent samples t-test. Based on past research, it is hypothesized that females tend to support prayer in schools more than males. Okay, so the assessment of your hypothesis, so result section would look like this. An independent samples t-test was conducted to examine the relationship between gender and support for prayer in schools. Females tended to support prayer in schools more than males. Okay, and all your stats. So again, I'm missing this word. You should say, and I'll adjust it. Females tended to support prayer in schools significantly more than males, right? And because P is less than 0.05. Okay. So what would this look like for your discussion section? You would say, as predicted, it was found that females tend to support prayer in schools more than males. You see how this is very simple and anyone can understand this. Whereas if you read this to someone, it might scare them. One way ANOVA. Let's say your hypothesis was based on past research. It is hypothesized that support for prayer in schools varies based on religious affiliation, or varies by religious affiliation. So then you would write this, and ANOVA indicated a significant difference somewhere among the religions on support for prayer in schools. Here's all your stats. Specifically, Christians support prayer in schools significantly more than, whatever these paired comparisons give you. So if you would restate your findings here, as predicted, it was found that support for prayer in schools varies based on religious affiliation. Specifically, Protestants and Catholics support prayer in schools more than atheists, ... I just threw that together, made it up, but that's how it should read. Okay, so that's what you're going to do, okay? And that's it. That's all I want for the first part of the discussion section. That's minimum. If you want to do something cool, you can do this as well. Okay? You can say, we'll just leave it at that. We'll leave it at that, but what you could also do in the first part of the section is you can bring back your literature review, and you could say, unlike Article 1 and Article 2, it was found that females tend to support prayer in schools more than males. Okay. Like Article 5 and 6, it was found that support for prayer in schools varies by religious affiliation. Specifically, Protestants support prayer in schools more than atheists. So basically in this section, you could kind of bring back your literature and compare and contrast. So you could do that if you want, but at minimum, just have one sentence for each of your findings, and I'll be happy with that. And say, as predicted, or contrary, if it was against your hypothesis. So if it was in line with your hypothesis, you would say as predicted. If it went against your hypothesis, you would say contrary to what was predicted, it was found that females ... Okay. So that's all. That's all you have to do, and all you have to do is the week 13 discussion, and this is due by Sunday, but let's take a look at it. Okay, copy and paste your results paragraphs. Okay, restate the findings from your results section in a way that anyone can understand. Okay, and this is the discussion first part. And again, this is what I just literally covered. be sure to watch the week 13 lecture video before you begin, which is this video. Respond to 2 other students, compare their paragraphs to what you learned in the week 13 lecture video. Also, please let them know if something is unclear and if possible, suggest a correction. Okay. And again, each of your responses need to be 100 words. Please dig deep, find something to say. Okay. Because you only have one assignment due this week, I expect you to work diligently to find the remainder of your articles for your literature review. Okay. You need a total of 10, so don't forget this. This is a good week to make sure you get all 10 of your articles and start writing your article summaries for part 2 of your introduction section, the literature review. Also, because this is your only assignment this week, I expect you to diligently resubmit your article summary rough draft, your introduction rough draft, your methods rough draft. And again, I'm going to get you your results rough draft as soon as I can. Okay. So let me know if you have any questions via email or show up to office hours. Okay. Remember, I'm here for your success. So definitely take advantage of that. Okay. Take care. Have a great evening.